force on a current carrying conductor in a uniform magnetic field. So this is 3-mark question. Now I have a magnetic field. Uniform magnetic field is applied. Uniform means you see the spacing between these field lines are equal. That is called as uniform. If they are unequal like this, they are non-uniform. Okay. So uniform magnetic field is applied. Now I will bring a conductor. This is a conductor which is carrying a current, and the conductor of length L and A is the area of cross section, and the angle between the conductor and the magnetic field is theta over here. Let me consider a small length element. This is a small length having dl is the length. I will call this as length element. And the electron here, and this electron is moving in this direction. So the drift velocity is in this particular direction. That's what you are observing. If all the electrons are moving in the upward direction, what should be the direction of current? The direction of current is downward here, you are observing, right? Okay. Then it experiences a force. That force direction can be found by right hand rule or Fleming's left hand rule. We will see it later at the end of the derivation. So force experienced by each electron in the conductor is F is equal to minus E into Vd cross B. So Q into V cross B, the same formula I am using. So you know this formula, right? F is equal to Q into V cross B. The same formula I am using it here. Negative sign because the charge of an electron is negative, and Vd is the drift velocity of the electron. If N be the number density of electrons, number density means number of electrons per unit volume. That is number density, and A is the area of cross section, and L is the length of the conductor. Then number of electrons in length dl is Na into dl. Na into dl is total number of electrons present in this particular length element dl. So that is number of electrons, total number of electrons in it. Force experienced by the electron in length element dl is df is equal to Na dl into minus A into Vd cross B. So one electron experiences this much force, then these many number of electrons will experiences this much force. So small force. So df is equal to Na dl minus E into Vd cross B. So I will rewrite it. So Na Vd. So Na Vd. So write it. And dl cross B. Here dl is the length vector. We are going to consider length vector. The direction of length vector is along the direction of current. In which direction the current is there? That is the direction of length element dl. So, but you know that I is equal to NEA Vd. This is from the previous chapter, current electricity, we know it. So just replace these terms by I. So what you are going to get in the next step, df is equal to I into L cross dl cross B. This is the force experienced by electrons in small length element, but all the electrons in a conductor experiences a force that is given by I F is equal to I into total length of the conductor cross V. So this is the force experienced by the conductor itself now. The force experienced by the conductor. And the direction of force is given by the right hand rule. So you have to curl your finger from L towards B. So where is L here? The L is along the direction of current. So the direction of L is taken in this direction. And what should be the direction of B? The direction of B is somewhere here like this, right? Now you have to curl your finger from L towards B. L is in this direction. L towards B. All the fingers you have to curl it. And where the thumb points? The thumb points upward. Upward coming out of the plane of the paper. So to understand that, let me take a diagram over here. So this is the diagram. So you see the direction of force. The direction of force is given by the right hand rule. You have to curl your finger from L. L is in this direction and B is in this direction. So L is in this direction and B is in this direction. Curl your finger from L towards B. So L towards B. Then the thumb points upward and that is coming out of the plane of the paper where I am writing it. So that is the direction of force. Or you can apply simply the Fleming's left hand rule, the direction remains same. It will be perpendicular to the plane of the board, perpendicular to the plane of the paper where I am writing, and upward. So finally what we got, the relation we got F is equal to I into L cross B, or we will get L cross B is nothing but LB sine theta, right? So I into LB sine theta, where theta is the angle between L and B, or theta is the angle between the direction of current and B. So this is the expression for force experienced by a conductor.